All right, so get this. Picture yourself. You're on a spacecraft, headed to Jupiter's moon Europa, but you're taking a little detour
A detour
it,
around Mars.
around Mars. It sounds crazy, right? But that's exactly what NASA's Europa Clipper just did.
Yeah.
So today we're diving deep into this maneuver, this fascinating maneuver, using insights from the article Europa Clipper, Mars Gravity Assist to Jupiter.
It's not just a random cosmic road trip, though. This Mars flyby, it was very meticulously planned. A gravity assist.
Hmm.
It's a technique where a spacecraft uses a planet's gravity to alter its path and speed,
Oh,
kind of like using a planet as a giant slingshot.
oh, wow.
And it's a crucial part of deep space missions.
I've always been fascinated by how we can use these celestial mechanics to our advantage.
Yeah.
But tell me, how much fuel and time did this Mars pit stop actually save for Europa Clipper?
That's a great question. In this case, the gravity assist from Mars shaved off a whopping 3 years from the total travel time to Jupiter.
Wow.
And in terms of fuel savings, it's substantial.
Okay.
We're talking about potentially thousands of kilograms of fuel saved.
Thousands.
Yeah, which translates to significant cost savings and allows for more scientific instruments to be packed onto the spacecraft.
3 years. That's incredible.
Yeah,
It really highlights the importance of these maneuvers for deep space exploration.
right.
But before we get too lost in the how,
Yeah.
let's talk about the why.
Okay.
Why are we sending this spacecraft on such an elaborate journey to Europa in the first place?
Right.
What's all the fuss about?
Europa is one of those celestial bodies that keeps scientists up at night
I can imagine.
because it holds the potential for harboring life.
Okay.
Imagine this. A moon with a massive salty ocean, or
Yeah.
perhaps even containing more water than all of Earth's oceans combined, hidden beneath a layer of ice.
It's almost too much to comprehend, really.
Yeah.
That's mind-boggling. A hidden ocean on another world.
Yeah.
It makes you wonder what could be lurking down there.
Right.
So Europa Clipper's mission is to investigate this possibility, right?
Exactly. It's equipped with a suite of cutting-edge instruments designed to analyze the composition and thickness of Europa's icy shell, search for signs of plumes erupting from the surface, and even map the ocean's depth and salinity.
Wow.
All of this data will help us determine whether Europa's ocean could truly support life.
It sounds like we're on the verge of some groundbreaking discoveries. Can you tell me more about the specifics of Europa Clipper's journey? It's not exactly a short hop across the cosmos, is it?
You're absolutely right.
Yeah.
It's more like a grand odyssey. Europa Clipper launched on October 14, 2024, and the Mars flyby, which happened on March 1st, 2025, was just the first step.
Okay.
It actually came within a mere 550 miles of the Martian surface. Pretty close.
A close shave.
Yeah. Then it's onto an Earth flyby
Yeah.
in December 2026 for another gravity boost. And finally, it'll reach Jupiter in April 2030.
Okay.
So we have a while to wait before it starts beaming back data from Europa.
It's amazing how we can plot a spacecraft's course with such precision across these vast distances. I read that it's like playing cosmic billiards, with the planets constantly in motion.
Right.
How do scientists even begin to map out a journey like that?
It's a phenomenal feat of engineering and mathematics.
Yeah.
Think of it this way. Imagine trying to hit a moving target.
Okay.
But the target is millions of miles away, and you only get one shot. It requires incredibly complex calculations and simulations, taking into account the gravitational pull of multiple planets and even the faint pressure from sunlight.
I can't even wrap my head around the level of detail that goes into those calculations. But it's clear that the team at NASA's JPL knows what they're doing.
Right.
They've been planning these intricate maneuvers for decades, from Voyager to Cassini and now Europa Clipper.
And even with all that planning, the journey isn't completely set in stone. They'll need to make mid-course corrections along the way.
Uh-huh.
The Mars flyby was actually a chance for them to fine-tune the spacecraft's trajectory, ensuring it stays on target for its ultimate rendezvous with Europa.
So they're constantly monitoring and adjusting the course.
Yeah.
It's like navigating a ship across a vast ocean, constantly making small adjustments to stay on course. But before we move on to Europa,
Yeah?
I'm curious to know more about what Europa Clipper was able to accomplish during that close encounter with Mars. It wasn't just about the gravity assist, was it?
No.
There was some bonus science happening too, right?
Absolutely. The team seized the opportunity to test two crucial instruments.
Okay.
A thermal imager, which captured stunning multicolored images of the Martian surface, and the radar instrument, which was getting its first real-world test.
Wow.
This particular radar is designed to penetrate the icy shell of Europa, and it couldn't be fully tested on Earth because of its massive size and the long wavelengths it uses.
I hear.
So the Mars flyby provided a perfect opportunity to make sure it's working properly before reaching its main target.
That's incredible. It reminds me of those iconic Voyager missions that used gravity assists to visit multiple planets back in the 70s.
Right.
Wasn't there a rare planetary alignment that made those flybys possible?
You're thinking of the 1977 alignment,
Yeah.
a once-in-a-176-year event that allowed Voyager 1 and 2 to visit Jupiter, Saturn, Uranus, and Neptune in a single grand tour.
Oh, wow.
It was a stroke of luck and a testament to the incredible vision and planning of the Voyager team.
What a remarkable feat. It's incredible how we've built upon that legacy of exploration with missions like Cassini at Saturn and Galileo at Jupiter and now Europa Clipper. Each mission adds to our understanding of the solar system and paves the way for even more ambitious journeys. But before we delve into the mysteries of Europa itself, let's take a closer look at the challenges of navigating a spacecraft through the vastness of space and how the team ensures Europa Clipper will reach its destination safely and efficiently.
That's a great point. The journey to Europa is fraught with challenges, from the harsh radiation environment of Jupiter to the sheer distance and communication delays.
Right.
But the team has implemented some ingenious solutions to overcome these hurdles, and we'll explore those in detail in the next part of our deep dive.
Stay tuned, folks. We're about to go even deeper into the intricacies of this groundbreaking mission.
Absolutely. Navigating a spacecraft through that vast expanse of space, it's really like conducting an orchestra on a cosmic scale.
That's a fantastic analogy.
Yeah.
So, what are some of the biggest hurdles the team has to overcome in getting Europa Clipper safely to its destination? We touched on the radiation environment around Jupiter earlier. Can you elaborate on that?
Yeah, Jupiter has the strongest magnetic field in our solar system.
Right.
And it traps charged particles from the sun, creating this intense radiation belt around the planet.
Oh, wow.
It's like a huge, invisible force field that can really wreak havoc on sensitive electronics.
Oh, so how do they protect Europa Clipper from being fried by all this radiation?
Well, for starters, the spacecraft is equipped with radiation-hardened electronics and shielding to help minimize the damage. But they've also designed the mission in a way that minimizes exposure.
Uh-huh.
So instead of orbiting Europa directly, which would subject the spacecraft to constant bombardment, Europa Clipper will fly by the moon in a series of elliptical orbits, dipping in close for observations and then swinging out to safer distances.
It's like minimizing your time in the danger zone.
Exactly.
Smart. Are there any other challenges they have to contend with on this long journey?
Well, another significant hurdle is the sheer distance involved.
Okay.
We're talking about hundreds of millions of miles.
Right.
And that means communication delays.
Right. So every command sent from Earth takes time to reach Europa Clipper, and every piece of data sent back takes time to reach Earth.
Exactly. And that delay increases as the spacecraft travels farther away.
I see.
At times, it can take almost an hour for a signal to travel one way.
Oh, wow. That's a long time.
Yeah, that means the team can't control the spacecraft in real time. They have to anticipate issues, plan maneuvers well in advance, and build in a degree of autonomy for the spacecraft to handle unexpected situations.
I imagine that makes things incredibly tricky for the mission controllers back on Earth.
Right.
It's almost like sending instructions to a rover on Mars, except the distances are even greater.
Absolutely.
Wow.
It certainly adds a layer of complexity.
Right.
They have to factor in these communication delays when planning observations, uploading commands, and even troubleshooting any issues that might arise.
Yeah.
But the team at JPL is incredibly skilled at this.
I bet.
And they've developed really sophisticated software and communication protocols to handle these challenges.
It's inspiring to see how we overcome these seemingly insurmountable obstacles to explore new worlds.
Yeah.
And speaking of overcoming obstacles, how does Europa Clipper even get the power it needs to operate so far from the sun? I mean, solar panels wouldn't be very effective out there, would they?
You're right. Solar panels wouldn't be practical at Jupiter's distance. Instead, Europa Clipper is powered by something called a radioisotope thermoelectric generator, or RTG for short.
Okay, so what exactly is an RTG? It sounds a bit like something out of a science fiction movie.
It might sound futuristic, but RTGs have been used to power spacecraft for decades.
Oh, okay.
They're essentially batteries that convert the heat from the natural radioactive decay of plutonium-238 into electricity.
Oh, wow. So they have their own built-in power source independent of the sun.
Exactly. That makes them ideal for missions to the outer solar system where sunlight is weak.
I see.
RTGs are incredibly reliable, long-lasting, and can operate in extreme environments.
That's impressive.
Yeah.
It seems like we've really thought of everything to ensure this mission's success.
Well, we try.
Now, before we wrap up this part of our deep dive,
Yeah.
I want to circle back to something we touched on earlier, the search for life on Europa.
Right.
You mentioned that Europa Clipper will be looking for evidence of plumes erupting from the surface. Can you tell me more about that? Why are plumes so important in the search for life?
So plumes, they're essentially geysers of water vapor and other materials that erupt from beneath the icy surface of Europa.
Okay.
Scientists believe these plumes originate from the subsurface ocean, and they offer a tantalizing opportunity to sample the ocean's contents without having to drill through miles of ice.
So if we can analyze the material in these plumes, we might get a glimpse of what's happening in Europa's ocean without actually landing on the moon.
Exactly. It's like having a window into the hidden world beneath the ice.
Right.
Europa Clipper is equipped with instruments that can analyze the chemical composition of these plumes, looking for signs of organic molecules, salts, and other telltale signs of a potentially habitable environment.
So the plumes are like little messengers from the ocean carrying clues about what lies beneath.
Exactly.
That's fascinating. But even if Europa Clipper finds evidence of plumes, doesn't actually confirming the presence of life require a future mission that can land on the surface and collect samples directly?
Yeah, that's the ultimate goal.
Okay.
Europa Clipper is a crucial step in that direction. It's gathering the data we need to assess the potential for life and to identify the most promising landing sites for future missions.
So it's like a scout, paving the way for a more ambitious expedition. I'm already excited to see what the future holds for Europa exploration.
Me too.
Welcome back to the Deep Dive. We've been exploring this incredible journey of NASA's Europa Clipper, a mission that's really pushing the boundaries of space exploration and, igniting our imaginations about the possibility of life beyond Earth.
It really captures the essence of scientific curiosity and human ingenuity.
Yeah.
We've talked about the intricate planning, the engineering marvels, and the daunting challenges of navigating across the vastness of space.
Right.
But now let's turn our attention to the ultimate destination, Europa itself.
This icy moon has captivated scientists for decades, and for
Yeah.
good reason.
Yeah.
We've touched on its hidden ocean, potentially teeming with more water than all of Earth's oceans combined. But what else makes Europa such a tantalizing target in the search for extraterrestrial life?
Well, Europa seems to possess, the key ingredients that we believe are essential for life as we know it.
Okay.
We call these the habitability requirements.
Right.
And they include things like liquid water, a source of energy, and the right chemical building blocks.
Okay, so we've established that Europa has plenty of water, locked away beneath its icy shell.
Right.
But what about the other two requirements? Energy and the building blocks of life. Doesn't sunlight play a crucial role in providing those on Earth?
Well, sunlight is certainly the primary energy source for life on Earth's surface,
Right.
but in the depths of Europa's ocean, where sunlight can't penetrate, we believe a different kind of energy source might be at play.
Okay.
Remember those hydrothermal vents we discussed earlier?
Yes, I do.
Yeah.
Those underwater geysers that spew out hot, mineral-rich water.
Right, exactly.
Yes, I remember you mentioned that they could be teeming with life, even in the absence of sunlight.
Precisely.
Yeah.
On Earth, we find these thriving ecosystems around these hydrothermal vents, completely independent of sunlight.
Wow.
They rely on a process called chemosynthesis, where microbes use chemical energy from the vents to produce food.
So instead of relying on sunlight, life forms on Europa could potentially be harnessing energy from these hydrothermal vents.
That's the idea.
Wow.
And it's not as far-fetched as it might sound.
Right.
The chemical reactions that occur around hydrothermal vents release energy that microbes can utilize to build the organic molecules necessary for life.
So Europa might have its own version of these deep-sea oases powered by chemical energy instead of sunlight.
It's possible.
That's amazing. What about the building blocks of life? What evidence do we have that those might exist on Europa?
Well, scientists believe that Europa's ocean is likely rich in salts and organic molecules, the essential ingredients for life as we know it.
Okay.
These could have been delivered to the moon through impacts from comets and asteroids, or they might have formed within Europa itself through geological processes.
So we have liquid water, a potential energy source, and the chemical building blocks.
It seems like
It seems like Europa has all the right ingredients for life.
Yeah.
But I have to ask, what kind of life are we talking about? Are we picturing complex organisms or something more along the lines of simple microbial life?
It's certainly fun to imagine what strange and wonderful creatures might exist in Europa's hidden ocean.
Right.
But given the extreme conditions, the darkness, the cold, the
Yeah.
pressure,
Yeah.
it's more likely that if life does exist on Europa, it would be microbial in nature.
Okay.
Think simple single-celled organisms adapted to survive in this extreme environment.
So no giant squid or bioluminescent jellyfish.
Probably not, but
Oh,
even finding microscopic life on Europa would be a monumental discovery.
oh, absolutely.
It would mean that life isn't unique to Earth, that it can arise and thrive in other parts of our solar system.
Right.
It would revolutionize our understanding of biology and open up the possibility that life might be far more common in the universe than we ever imagined.
It's an incredibly exciting
It
prospect.
is.
So, as we eagerly await the arrival of Europa Clipper at Jupiter, what are some of the key things we should be looking for in the data it sends back? What would be the most compelling evidence for the existence of life on Europa?
Well, one of the most promising avenues is the search for biosignatures.
Okay.
These are chemical or physical traces that could indicate the presence of past or present life.
Uh-huh.
For example, certain ratios of isotopes in the water or the presence of specific organic molecules could be strong indicators.
So Europa Clipper will be acting as a sort of cosmic detective, searching for these subtle clues that might point to the existence of life.
Exactly. It's a mission of discovery driven by the fundamental human desire to know whether we are alone in the universe.
Yeah.
And with Europa Clipper, we're getting closer than ever to answering that profound question.
It's an incredible time to be following space exploration.
It is.
This mission really embodies our collective curiosity, our ingenuity, and our unwavering determination to push the boundaries of knowledge. And who knows what amazing discoveries await us on Europa.
This deep dive has taken us on a journey through the intricate world of space exploration, highlighting the remarkable achievements of scientists and engineers who are pushing the limits of what's possible.
Absolutely.
It's a testament to the power of human curiosity and our enduring quest to understand our place in the cosmos.
As we conclude this episode, we invite you to join us in marveling at the wonders of the universe and to ponder the profound implications of finding life beyond Earth.
Yeah,
Keep looking up, keep asking questions, and keep exploring.
that's it.
The cosmos is full of mysteries waiting to be unraveled, and perhaps somewhere out there, another world is waiting to reveal its secrets.